electronegativity. Electronegativity. Electron affinity is completed in the last class. Next, electronegativity. Yes, tell me. Electronegativity. Only ionization energy. Okay. Atomic structure. Atomic structure. First topic, fundamental particles. Fundamental particles. We have three fundamental particles: electrons, protons, and neutrons. Electrons, protons, and neutrons. Okay. Let us see first discovery of electrons. Discovery of electrons. Who discovered electrons? J.J. Thomson. J.J. Thomson with the help of a discharge tube. Okay. Discharge tube experiment. See, what is a discharge tube? Discharge tube is made up of a glass, okay, having two metal plates at two ends. This is one metal plate, this is another metal plate, okay, and it is having two inlets. This is one inlet, this is one inlet. This is used to pass H2 gas or any other gas like O2 gas, right? And this is used to connect to vacuum pump, to vacuum, right? And these two metal plates are connected to high voltage battery. High voltage battery. High voltage battery. Okay, right. See some important points about discharge tube. We pass the gas which is at very low pressure. That is very, very important condition. Gas should be at a low pressure. Voltage should be high. That is very, very important, right? Gas at a low pressure and high voltage. High voltage, right? Next, see, negative terminal of the battery is connected to negative plate, positive terminal of the battery is connected to positive plate. Okay, negative, positive. What happens when we pass H2 gas and when we pass high voltage current? See, let us pass H2 gas. H2 molecule, H2 molecule. First molecules enter into the chamber, discharge tube, and we are supplying high voltage current, right? High voltage means energy. Due to that high energy, first molecule undergo dissociation. Molecule undergo dissociation into atoms. Atoms. See, we are passing H2 molecule, right? And we are passing high voltage. High voltage means high energy. Due to that high energy, molecule get dissociated into atoms. See, H2 will become two hydrogen atoms, and we are supplying high voltage or energy continuously. That atom undergo ionization to produce electrons. So what is the source of electrons in the discharge tube experiment? How they are generating? You are sending the gas, right? So that is the source of electrons. Clear? How electrons are generating? What is the source of electrons? Gas you are sending in the discharged. Okay, right. Instead of H2 gas, if I take O2 gas, what happens? If I take O2 gas, 2 oxygens, 2 O plus, and again 2 electrons. If we send H2 gas or if we send O2 gas, same phenomena takes place. First molecule undergo dissociation, means the molecule will become atoms, and atoms undergo ionization to produce electrons. Once observe carefully, what is the formula of the electrons when we take hydrogen gas in the discharged? What is the formula of the generated electrons? E minus. What is the formula of the electrons when we take oxygen gas? E minus. Is there any change in the formula? Is there any difference in the formula? No. So nature of the electrons, very important point. The nature of the electrons is independent on the nature of the gas present in the discharge tube. You can take H2 gas or O2 gas or N2 gas or any gas. What is the formula of the generated electron? E minus only. Very important point. Another name for electrons, discovery of electrons are cathode rays. Cathode rays. Nature of the cathode rays is independent on the nature of the gas present in the discharge tube. Whatever the gas, whether it may be H2, Cl2, O2, any gas you can take. The generated electron formula is E minus only. So nature of the nature of the electron or cathode rays is independent on the nature of the gas. Very important point. Okay, right. Next, let us see another important point. Or under properties we can write all these properties. Electrons travel in a, tell me, electrons travel in straight line. Some important points I am giving. Electrons travel in straight line. Electron possess kinetic energy. Electrons are having kinetic energy. Electron is having mass. I am giving in the short definitions, right? They travel in a straight line. Electron possess kinetic energy. Electron having mass. And one more important point: when electrons are passed through electric field, they get deflected towards positive plate. Why they get deflected towards positive plate? Because they are having negative charge. Okay, they are having negative charge. That's why they get deflected towards positive plate. Very important. And nature of the this is only the important point out of all. Nature of the electrons are cathode rays. Cathode rays is independent. Is independent on what? Is independent on the nature of the gas. On this 2 times scheme. On the nature of the gas. Okay. This is only the most important point. Cathode rays are independent on the nature of the gas or nature of the metal plate. They do not depend on anything. Okay, right. That is enough about the discovery, because this is the revision class. So let us go to the main table, important table. Everyone should learn this. Okay. Particle, charge, mass, E by M value, charge to mass ratio, electron. What is charge over electron? Charge minus 1.602 into 10 to the power of minus 19 coulombs, or minus 4.8 into 10 to the power of minus 10 ESU, electrostatic unit. ESU stands for electrostatic unit. Okay. Mass 9.11 into 10 to the power of minus 28 grams, or 9.11 into 10 to the power of minus 31 kilogram. E by m value. E by m value means, see, we know charge and we know mass. Charge to mass ratio. This is also called as specific charge. Specific charge. Specific charge. Charge to mass ratio. E by m value. Okay, or specific charge. What is its value? 1.75 into 10 to the power of 11 coulomb per kg. These values are very, very important. You have to by heart all these values. Okay. Similarly, proton, say fastly. Proton.
Yes,
Proton. This is minus now. So plus 1.602 into 10 to the power of minus 19 coulombs. Or this is minus, so plus 4.8 into 10 to the power of minus 10 ESU. Right, and the mass of the proton mass 3.1, 1.672 into 10 to the power of minus 24 grams. Okay. E by m values are very, very important. Charge to mass ratio values. 9.58 into 10 to the power of 7 coulomb per kg. Okay. And neutron. What is charge over neutron?
0.
Neutron charge is 0. Mass of the neutron is 1.675 into 10 to the power of minus 24 grams. See, 1.67 to 1.675. 1.67 to 1.675. And what about E by m value?
0.
This table is very, very important. In de Broglie theory, we use this data. We use mass, we use charge mass comparison. Okay. Now, by seeing these values, which is a heavier fundamental particle, which is having more mass here, which is heavier fundamental particle? 1.675. See, actually here minus 24 is there, minus 28 is. Minus 24, minus 28. Minus 24 is bigger value. Okay, minus 24. So, which is heavier particle, heavier fundamental particle? Heavier particle or heavier fundamental particle? Neutron. This is very, very important information. Okay, and the lighter fundamental particle, which is having less mass, lighter particle is electron. Electron is the lighter particle. And specific charge values also very, very important, right? And we have another important particle. This is alpha particle. Actually, alpha particle is not the fundamental particle, alpha particle, but we should remember the formula of alpha particle. Alpha particle is He plus 2 helium nucleus. Helium nucleus is called alpha particle, right? Let us compare the E by m values of all these things. Alpha particle is having charge 2 and mass of the alpha particle. What is helium atomic mass? Helium atomic mass 4. Like that, we can calculate the E by m value. Let us compare the E by m values. E by m values of electron, proton, neutron and alpha particle. Right, arrange this. Which is having less E by m value? Neutron is less than, alpha particle is less than, proton is less than electron. You should by heart this. Okay, we can get by calculation also, but it takes time, so better to remember the E by m value order. Which of the following is the correct E by m order of alpha particle, neutron, proton, electron? That is the question. Clear? Right? Okay, we did discovery of electron, discovery of proton, neutron, not that much important, just leave it. And one more important point I wanted to give you. The specific charge of the electron is independent on the nature of the gas present in the discharge tube. But the specific charge of the proton, nature of the proton depends upon the gas present in the discharge tube. I will show you. See, electron means negatively charged particle. Okay, electron means negatively charged particle. Proton means positive. Proton means positive. You tell me, when we take hydrogen, What is the mass of this positively charged particle H? What is H mass? Hydrogen mass 1. Oxygen mass 16. When you take hydrogen, the generated positive particle mass is 1. When you take O2, the generated positively charged particle mass is 16. See, difference is there. Difference is there or not? In case of electrons, there is no difference. The generated electron is same only. When you take H2, when you take O2, when you take Cl2, 2 minus 2, 2e minus 2e minus 2e minus 2e minus. Is there any change in the formula of the electron? No. But when you take H2, different positively charged particles are generating, means different protons are generating. So nature of the protons depends on the nature of the gas present in the discharge tube. Very, very, very important part. Nature of the electrons is independent on the nature of the gas. Nature of the protons depends on the nature of the gas present in the discharge tube. Clear? I'll write that formula also. Okay. Statement. This is very, very important. See, the E by M value, specific charge of electron or nature of electron is independent. Is independent on nature of the gas. Nature of gas. Just now I have shown, right? E minus, E minus, E minus, E minus. In every case, E minus only. But E by M value of proton depends on nature of gas. Nature of the gas. Okay. Got it? Right. Next, nature of light. Nature of light. You have to by heart the table. Nature of the light. See, light travels in the form of wave. This is source of the light. Light travels in the form of waves. Okay, wave nature. Light possesses a wave nature. Okay. See, if we talk about wave, then we can talk about some parameters related to the wave. What are that parameters, sir? Wavelength, frequency, wave number, velocity. Yes, sir? Velocity. Simple concept of nature of light. Light travels in the form of wave. When we talk about wave, we can talk about some parameters, right? First one, wavelength. Wavelength, it is lambda. See, this is source of light. This is basic information. Wave contains two parts. Upper part is called as crest, lower part is called as trough. Okay, crest and trough. This is crest. This is trough. Distance between two successive crests or two successive troughs is called as wavelength. Simple definition. Distance between two successive crests or distance between two successive troughs is called as wavelength. Any doubt in the wavelength? Distance between two, tell me, two successive crests is called as wavelength. Or two successive troughs also you can take, right? Once one question came in the NEET based on this idea. Okay, definitions are very, very important. And wavelength symbol is lambda. And what are the units of wavelength? Units: angstroms, nanometer, picometer. Wavelength is measured in angstroms, nanometer, picometer. Tell me fastly, 1 angstrom is equal to 10 to the power of minus 10 meter. 1 picometer is equal to 10 to the power of minus 12 meter. 1 nanometer is equal to 20. Kata, over. No need to do any research on this definition. Wavelength definition is our distance between two successive crests or two successive troughs. Okay. Next, frequency. Frequency. I'll finish fastly because we have to discuss Bohr's atomic model. That is very, very important. I'll finish fastly. Frequency symbol is nu. What is frequency? See. Let us take one imaginary point. Okay. This is source of light. Let us consider this is one wave. Just imagine one crust and one trough. One crust and one trough is considered as one wave. Okay. I'll use another color. This is second wave, third wave, fourth wave. See how many waves are present here? 1, 2, 3, 4. Just we are considering one crust and one trough as one wave. One crust and one trough. One crust and one trough. One crust and one trough. One crust and one trough is considered as one wave. So total how many waves are there? 1, 2, 3, 4. The number of waves that travel through a point in 1 second. 1 second time. In 1 second time, from the light source, how many waves that pass through this point, imaginary point, is called as frequency. The number of waves that travel through a point in 1 second time is called as frequency. In this diagram, what is the frequency? 4. Because how many waves are crossing through this point, passing through this point? 4. So frequency is 4. Definition: the number of waves that pass through a point in 1 second. In 1 second is called as frequency. What are the units of frequency? Frequency units are, what are the units of frequency? Second inverse, hertz, CPS, cycles per second, and all these are equal. 10 second inverse is equal to 10 hertz. 10 hertz is equal to 10 CPS. If you get 100 hertz, you can take it as a 100 second inverse. Okay. So definition, symbol and units. Right. Okay. Wave number. Fundamentals only, so we can finish fastly. Wave number 1 by lambda r nu bar. 1 by lambda r nu bar. Reciprocal of wavelength. Reciprocal of wavelength is called as wave number. Over. Units are centimeter inverse. Small definition. Units centimeter inverse. So wave number nu bar is equal to 1 by lambda. Remember this formula. Wave number can be represented as nu bar. Reciprocal of wavelength is called as wave number. Last topic, velocity. Velocity of light. What is our heading? Nature of light, right? So light travels with the speed of, tell me, 3 into 10 to the power of 8 or 10? 8 meter per second or 10 to the power of 10 centimeter per second. You have to remember this value. Okay, right. So we completed wave parameters. Okay, and one more point, amplitude also. This is also important. Amplitude. In future we will get this word amplitude. Amplitude. Anybody, can you give the definition of amplitude? The height of the crest. Height of the crust or depth of the trough. Height of the crust or depth of the trough is called as amplitude. Amplitude. Okay. Next, electromagnetic spectrum. Electromagnetic spectrum. You know about wavelength? Wavelength definition. Wavelength, wave number. Frequency. Wavelength, wave number, frequency. Electromagnetic spectrum is the arrangement of all types of radiations in the increasing order of their wavelengths. This is very, very important. First, cosmic rays. Cosmic rays, you have to remember this order: cosmic rays, gamma rays, next, tell me, X-rays, UV, visible, next, infrared rays, microwaves, and radio waves, okay. Right, now see this, left to right, lambda increases, wavelength increases. Left to right, wavelength increases, which are having more wavelength? Radio waves are having more wavelength, more lambda, okay. And what about cosmic rays? Less wavelength, and see, another line I am taking. Frequency increases in this direction. Frequency increases. This is having more frequency. See, you have to by heart this. Order as it is. For example, let us see these two. UV rays and visible rays, which are having more wavelength? Visible and IR, which are having more wavelength? IR. Now, cosmic rays and X-rays, which are having more frequency, more new? Cosmic rays are having more frequency. And very, very important relation. In the next topic, we will discuss that only. Energy is equal to H nu. E is equal to H nu. Right? Frequency is directly proportional to, you tell me, frequency is directly proportional to what? Energy. So high energetic radiation, tell me, high energetic radiation is cosmic. Why? Frequency is more. If frequency is more, energy will be more. High energetic radiation. Low energetic radiation is radio waves. Frequency is less. Clear? So just practice this, okay, right. And next, relation between all these things, I forgot to give you. We will have numericals on this. Relation between, tell me, wavelength, frequency, wave number, and velocity of light. Tell me fastly. Nu is equal to C by lambda. Nu is equal to C by lambda. Nu is equal to C. 1 by lambda can be written as nu bar, since 1 by lambda is equal to nu bar. Okay. This is about electromagnetic radiation. Next, Planck's quantum theory. Planck's quantum theory. According to Planck's, this is Earth, this is Sun. See, radiation or light, any light or electromagnetic radiation travels discontinuously like this, okay, not in the continuous fashion, discontinuously. Light or radiation, from sun will get radiation, okay. Light or radiation travels discontinuously in the form of small energy packets, which are called as quanta. According to Max Planck, light or radiation travels discontinuously, but not continuously, okay. And energy of this radiation is proportional to frequency. Just now I given one formula, okay. Remove proportionality, H nu, and you have to remember Planck's constant value, okay. This is Planck's equation, E is equal to H nu, very, very important. Can I write like this? H, what is nu? C by lambda. And what is the relation between energy and wavelength? Remember this. All these are very, very important. I am giving star marks for this. right? Energy is always proportional to wavelength, and h is equal to constant, called as which constant? Planck's constant, and h value 6.625 into 10 to the power of minus 27 erg second, or 6.625 into 10 to the power of minus 34 joule second. Okay, here just remember the formula and Planck's constant value, because we use Planck's constant directly. Okay. Next, Einstein's theory. Einstein's theory. According to Planck's theory, you tell me, light travels continuously or discontinuously? Discontinuously, in the form of small energy packets. According to Einstein's theory, light travels discontinuously in the form of energy particles called as photons. Okay. Quanta for Planck's, photon for Einstein. That is the difference. Quanta is introduced by Planck, photon is introduced by Einstein. Everything is same. Energy packets, energy particles. Energy packets is Max Planck. Particles is Einstein's. Same equation, but small change in energy. E is equal to energy. Where n is equal to number of photons. H is same, everything is same. Okay. Sometimes we have to calculate number of photons emitted by the bulb. Okay. One value I will give you. 1 watt is equal to 1 joule second. 1 watt is equal to 1 joule second. In numericals we use this. 1 watt is equal to 1 joule second. Remember this unit. Okay, right. Next concept, photoelectric effect. What is the photoelectric effect? See, the emission of electrons from the metal surface when light falls on the metal surface. For example, this is one metal surface. When light falls on the metal surface, electrons will eject out from this metal surface. This is called as photoelectric effect. The ejection of electrons from the metal surface, when light falls on metal surface. Okay. This is a metal surface. Let us take magnified metal atom. This is metal atom, and this is nucleus of the metal atom, and this is electron. We know between electron and nucleus attraction forces are present. Right. Now let us pass the light. Allow the light to fall on the metal surface, and imagine we are sending 100 joules energy light, okay, onto the metal surface. How much energy we are passing? We are supplying 100 joules or 100 kilojoules energy. Out of 80. Out of this 80, some part is utilized to overcome the nuclear attraction. And remaining part is used to eject the electron, to push the electron in the upward direction. For example, see, electron is tightly held by, this is nucleus, this is electron. Okay, I am passing the light ray. later. Now this nucleus is holding the electron tightly. So in this hand, how much energy is present? 80 joules energy is present. Out of this 80 joules, some 30 energy, 30 joules is utilized to remove the electron from the nucleus. Okay, and remaining energy is used to push the electron in the upward direction. Okay, when light falls on the metal surface, electron will eject out. Why? I explain the story now. Clear? Nucleus is tightly held by the electron is tightly held by the nucleus. Here attraction forces are present or not. So some energy is needed to overcome the attraction forces. Once again, see, this is electron, this is nucleus. Nucleus is holding the electron tightly. Light is falling on the surface. Some of the energy of this light is utilized to remove the electron from the nucleus. Attraction power means these will be removed. Nuclear attraction is removed or not. Now this is free electron, but it needs some initiation for the movement. Okay, remaining energy is used to push the electron in the upward direction. So the supplied energy is dividing into how many parts? Tell me. The supplied energy is dividing into how many parts? Two parts. First part is
To play there.
To exit the electron from the metal.
First part is to overcome the nuclear attraction force. Second part, are you getting or not? See, this is nucleus, this is electron. Okay. In this, how much energy is present? 80. Out of 80, let's say some 40 is used to remove the electron from the nucleus. Now electron is free. See, first nuclear attractions are present. Nuclear attractions were erased, removed. Now electron is free. So remaining 40 is there. We used 40 to overcome this force, and remaining 40 is there. Now that is used to push the electron in the upward direction. Clear? So we can write like this. See, you are supplying energy. You are supplying energy E. That energy E is divided into how many parts? Two parts. First part is W. See, the energy required to overcome the nuclear attraction force is called as work function or threshold energy. See, this is work function. The energy required to overcome the nuclear attraction, this is nucleus, this is electron, is called as work function. And the remaining energy which is used to push the electron is called as kinetic energy. If you do not get about this explanation, nothing to worry, just go through the expression. What is E here? Energy of the incident radiation. Energy of the incident radiation. W is the work function. Work function also called as threshold energy. K stands for kinetic energy. Now let us expand the formula. E is a form of energy or not? Tell me, what is the formula for energy? H nu. W also a form of energy, work function, threshold energy. So energy H nu naught and kinetic energy. From this you tell me kinetic energy is equal to, send H nu naught this side, H nu minus H nu naught. Send H nu naught this side. And kinetic energy is equal to, take H common, nu minus nu naught. This is constant or not?
Yes.
Constant. So if we remove constant, kinetic energy is directly proportional to frequency term. Kinetic energy is directly proportional to frequency term. Kinetic energy of the ejected electron is depending upon what? Tell me. Kinetic energy of ejected electron is depending upon frequency. So this is the graph. Very, very, very important. Kinetic energy of the ejected electrons and a frequency. Don't start the graph from the origin. See, I didn't start graph from the origin because minimum some energy is needed. Yes or no? Okay, so don't start the graph from the origin. If you start graph from the origin, kinetic energy will be 0. Okay, clear? So first formula, second formula, and graph. Kinetic energy and frequency. Kinetic energy of the photoelectrons directly proportional to what? Directly proportional to frequency. Observe carefully, line is not starting from origin. Clear? We will get a graph which is starting from the origin. That is wrong. Okay. This formula is also okay. Definition is okay. Clear? Right. Less probability for the NEET. That's why I am teaching very fastly. Okay. Next, another important one. number of photoelectrons emitted. Number of photoelectrons emitted. Number of photoelectrons emitted is depends upon the intensity. Intensity means number of photons which strike the metal surface. Number of photons which strike the metal surface. How many electrons are ejected? See, your electrons are ejecting out, right? Ejecting or not? That depends upon what? Means from the metal surface, how many electrons will come out? How many electrons will eject out? That depends upon the intensity. What is intensity? What is intensity? This graph also, okay? I'll explain about this term, intensity. Intensity. Number of photons which strike. Number of photons which strikes metal surface. I'll tell you one simple example to you. Just imagine one bench in front of you. One bench in front of you. Okay. Place two balls, 1 and 2. Okay, with some distance. Okay. Means two electrons are present on the surface or on the bench. Take another ball. This is photon. Throw. So how many photons you are throwing? How many balls you are throwing? You are throwing one ball. So how many balls will eject out from the bench? One only. Why? How many balls you are throwing? One ball only. For example, throw two balls. Throw two balls. How many electrons will eject?
2.
Number of photons which strike the metal surface. Number of photons. This is photon. This is also photon. Imagine electrons on the bench. Balls on the bench are electrons. You know, this is bench. You kept two balls, means two electrons. You are holding two other balls, means two photons. You are throwing like this. If you throw two photons or two balls, then two will eject out. Clear? Number of photoelectrons emitted is directly proportional to intensity. Intensity means number of photons which strike the metal surface. Clear? This is important. Just imagine that story. What story? On the bench, some balls are there. You are throwing some other balls. If you throw one ball, one ball only will come out. One electron only will eject out. Clear? Now intensity means number of photons. Number of photons strike the metal surface. Clear? Online students, okay. Next, very important. Let us go slowly now onwards. This is like a basic idea. Okay. Question coming area is from the Bose model onwards. Okay. Now we will go very slowly. For NEET or JEE, Bose onwards, the topics are very important. Bose model, hydrogen spectrum, de Broglie theory, Heisenberg uncertainty, quantum, orbitals concept, electronic configurations. Okay. Right, all these are basics. What I explained to you are some basic type concepts. Clear? Right, Bose atomic model. Bose atomic model. I'll give you points in shortcut way. According to Bose theory, electrons revolve around the nucleus in closed and fixed circular paths. Electrons revolve around the nucleus in closed and fixed circular paths, which are called as orbits or shells or energy levels. Orbits or shells or energy levels. Okay. Clear? What is the first postulate? Electrons revolve around the nucleus in closed and fixed circular paths, which are called as orbits or orbits or shells or energy levels. These orbits or shells or energy levels are designated as 1, 2, 3, 4 or K, L, M, N. K, L, M, N. K shell means first orbit. First orbit. K shell. Second orbit. L shell. Third orbit. M shell. Fourth orbiter. N shell. This idea is also very, very important. I'm giving only one. You have to remember second one also. Second orbit means which shell? Which shell? L shell. Third orbit means M shell. First point is clear. No doubt in the first point. Next. While electron is revolving around the nucleus, for example, one electron is revolving in the first orbit or it is revolving in the third orbit. While electron is revolving in the orbit, it neither loses energy nor gains energy. Neither loses energy nor gains energy. Okay. Second point is clear. Okay, electron neither loses nor gains energy by itself. But what happens when you supply energy to the electron which is present in the first orbit or first energy level? When you supply energy to the electron which is present in the first orbit, it jumps to second energy level or higher energy level. This is called as excitation. When we supply energy to the electrons, it jumps to higher energy level. Opposite. Let us consider one electron is present in the second orbit. If electron loses energy, it jumps to lower energy level. So when electron gains energy, it jumps to higher energy level. When electron loses energy, it jumps to lower energy level. And energy difference between two energy levels, first, second, third, and so on, is given by delta E. Delta E is equal to E2 minus E1. Energy of higher orbit and energy of lower orbit. E2 means consider always higher orbiter. You can take these two, then higher is 2. You can take these two, then higher is 3. E2 minus E1. Delta E is equal to E2 minus E1. Clear? Right. Next another important point. The angular momentum of the electron is quantized. Angular momentum of electron is quantized. And what is the formula for that angular momentum? mvr is equal to nh by 2 pi, where n is equal to orbit number. First orbit, second orbit, third orbit, fourth orbit, like that. Okay. Postulates are clear. K, L, M, N, 1, 2, 3, 4, and angular momentum mvr is equal to nh by 2 pi. Right. Now learn today these formulas. Okay. Without fail, I'll give you formulas of energy and radius and velocity. Okay. Tomorrow I'll explain some other concept to come numerical part. Tomorrow and day after tomorrow. Right. Energy of the electron. En stands for energy, or I'll give you heading energy of the electron. Energy of electron in nth orbit. En, energy of the electron in nth orbit is equal to any idea? Any idea? Minus 13.6 into z square by n square ev per atom, electron volt per atom. All the values are very, very important. Minus 313 into z square by n square kilocalorie per mole, or minus 1312 into z square by n square kilojoule per mole. You should learn every value. Okay, sometimes you will get question to calculate the energy of the electron in kilojoules, in kilocalorie, in eV. Clear? Next, minus 2.178 into 10 to the power of minus 11 into z square by n square, z square by n square, joule per atom. Sorry, erg per atom. Okay, erg per atom, or minus 2.178 into 10 to the power of minus 18 into z square by n square, joule per atom. All are very, very important. Sometimes you have to calculate energy in ergs, sometimes in joules. So every formula is important. Don't skip any single formula. What is Z here? And one more important point, all these formulas are Bohr series applicable to hydrogen and hydrogen-like systems. This is applicable to hydrogen-like system, hydrogen, helium plus, lithium plus to beryllium plus 3. One electron is present in all these. Hydrogen, Bohr's model is applicable to all these. All these formulas are applicable to these systems. All these are having one electrons. Clear? Right? Where Z is atomic number. When you get the question related to hydrogen, take atomic number as well. When helium plus is given, atomic number is 1 or 2?
2.
He plus, no? Atomic number never changes. Atomic number never changes. If you observe He plus, take atomic number 2. If you get lithium plus 2, 3. Beryllium plus 3, 4. Atomic number never changes. Okay? And N means orbit number. N is orbit number. Right? Radius, Rn. Radius of the nth orbit. Radius of nth orbit. Rn is equal to 0.529 into n square by z. N square by z angstroms. Where n is? Tell me. N is orbit number. N square by z angstroms of the electron. Vn, velocity. What is formula for velocity of electron? 2.18 into 10 to the power of 6 into z by n meter per second. Velocity of the electron. Say Z is atomic number, N is orbit number. Okay.